So this is actually page 2 that we're going to be working on in this period. Let's look at number 14. And it says simplify the following complex expressions. Guys, when you simplify variable expressions that have the variable I in there, the imaginary value I, it's as easy as this. You treat it like any other variable, like x. The only difference between x and I is that if you ever have an x squared, you have to change that to a -1. It's that simple, guys. So you could just pretend that these guys are x's. What would you do? Well, it's a subtraction problem. Distribute the minus sign. So everybody go ahead and distribute the minus sign into both of those. What we have is 10 minus 4i minus 7 minus 3i. I distributed the minus sign. I got this in red. Change the sign to negative, change the sign to negative. These first terms, there's nothing to distribute, so I just brought them down outside of the parentheses. Now let's combine like terms. On a complex number, you always want the real part first. 10 take away 7, that is 3, the nice real number 3. And then negative 4i minus 3i, that's negative 7i, and we are done. The next one is exactly the same. There's a plus sign. If you distribute a plus sign, it doesn't change anything. And there's nothing to distribute over here. So you kind of could forget about the parentheses. You could like pretend that they're not there, right? And just start combining the real part, negative 3, with the real part, positive 18. That'll give you a positive 15 as a real part. And then the imaginary 5i minus 7i, that's going to give you a minus 2i. That's your answer for 15. Ridiculously easy. Adding and subtracting, it's just like combining like terms. This is where it gets a little bit more interesting, where you actually multiply and you end up with I squared, which you'd have to change to -1. So you have a binomial times a binomial. Let's distribute one of these at a time. So let's distribute the 2 first. 2 times 2 is 4. 2 times negative 3i is negative 6i. And then you distribute this positive 3i. Positive 3i times 2, that's a positive 6i. Positive 3i times negative 3i is a negative 9i squared. Now, we need to combine like terms and also change the I squared to -1. That's what we need to remember, that I squared really does equal -1. So wherever you have an I squared, you have to replace it with the -1. So the middle terms, the negative 6i and the positive 6i, those happen to cancel out. They're gone. They disappear. What do we have left? We have a nice, beautiful 4 in the front, and the minus 9 times -1, that ends up being a plus 9. So 4 plus 9 is 13. There's our answer for number 16. Moving on. Let's do the same for this one. By the way, number 16, why did the i's cancel out? Because we had a binomial times its conjugate. Whenever you multiply a binomial with the same exact binomial, but the middle sign are opposites, that's called the conjugate, and that completely eliminates all the imaginary values. You end up with a real number. And that comes in handy in future problems. Now right here, the i's are not going to completely eliminate because this is not a conjugate of this. Let's see what happens. 3 times 5, 15. 3 times negative 6i, negative 18i. 4i times 5, positive 20i. And 4i times negative 6i is negative 24i squared. Again, we're going to combine the middle terms this time. They do not cancel. If you owe 18 i's and you have 20 i's, you're going to have 2 of those i's left over. Now the 15, you're going to bring it down. And over here you have negative 24 times -1. That ends up being a plus 24. So what we need to do now is combine the real part 15 with the real part 24. So when we combine 15 and 24, we get 39. Let's write that real part first, 39, and then put the imaginary part second, plus 2i. We're done. Again, the imaginaries are still here because we did not multiply a binomial by its conjugate, complex conjugate. So that's why the imaginaries did not eliminate like the previous one did. 18 and 19, these are very interesting problems because they have square roots and imaginary values. These are the type of questions you're going to have on the final itself. Let's distribute, same deal, distribute a negative times a positive will be a negative. And when you have the square root of 3 times the square root of 7, you could actually multiply those together and put them underneath one square root, the square root of 21. Okay, and then you go negative square root of 3 times I, negative I. Well, again, a negative times a negative. First start off with the signs. A negative times negative is a positive. and then you have the square root of 3 with I. You can't really do that. Let's just put them together. And I always say put the imaginary variable first, and then the square root of 3 second. Okay? And now let's distribute this positive 4i times positive square root of 7. So we're going to put positive times a positive is a positive, and we're going to just write it all together. You can't really multiply anything. So you're going to put the 4, the I, and then the square root of 7. And then last but not least, we are going to take the positive 4i times the negative I. Positive times a negative is a negative. Put the 4, and then I times I is I squared, which we should all know that that I squared becomes a negative 1. So let's see what we could combine. We can't combine anything. Not even this middle I with this other I, because you have I with the square root of 3. If this were a square root of 3, then yes, you could combine them, but they're not the identical same term. Okay, so we're just going to leave it. The only thing we could do to make this look a little nicer is change this I squared to a negative. So our final answer is going to be negative square root of 21 plus I square root of 3 plus 4i square root of 7 plus 4. Why plus 4? Because a negative 4 times a negative 1 is a positive 4. Moving on. Number 19. Again, let's distribute. Square root of 2 times square root of 5. What's that? Square root of 10. Thank you. How about square root of 2 times I? How do I write that? Plus I square root of 2. Okay, and then the next one, let's distribute negative 7i times square root of 5. How do I write that? You first begin with the sign. What's a negative times a positive? Negative. And then you put the 7, the I, and then the square root of 5 at the very end. Last but not least, negative 7i times positive I. What's that? Negative 7 with an I squared. And we should all remember that the I squared is really a negative 1. So what's the only thing that changes here is that I squared to a negative 1, which makes it a positive 7. Everything else stays exactly the same. So our final answer is square root of 10 plus I square root of 2 minus 7i square root of 5, and then plus 7. That's your final answer for number 19. Number 20. We need to remember that we do not want i's in the denominator. We don't want the variable I in the denominator, and we do not want square roots in the denominator. So either way, whether you're dealing with 3 minus I or 3 minus the square root of 2, doesn't matter if it's I mean, right here we're dealing with both 3 minus I and the square root of 2. Either way, you have to multiply by its complex conjugate. So what is the conjugate of this binomial? It's the same exact binomial, but you put a plus sign in between the two terms. Now, of course, what you do to the bottom, you must do to the top. So let's begin. This is like 3 problems here. Let's begin with the bottom. Let's distribute. We have 3 times 3, that's 9. We have 3 times I square root of 2. You're just going to put plus 3i square root of 2. And then we're going to distribute negative I square root of 2 times 3. Negative times a positive is a negative. You're going to put the 3 first, then the I, then the square root of 2. And then negative I square root of 2 times positive I square root of 2. A negative times a positive is a negative. I times I is I squared. And the square root of 2 times the square root of 2 is what? The square root of 4. Thank you very much. So what happens with these middle terms? They cancel out. We already know that when you multiply a binomial by its conjugate, the middle terms cancel out. The i's end up disappearing. The square roots end up disappearing. These guys are gone. Now, we have a negative I squared. What's the I squared really? Okay, so what we really have is a negative 1, which we know it's going to become what? Positive 1. So we could just put the plus right there. And this value of positive 1, we need to multiply it by the square root of 4. But what's the square root of 4? 2. That's really just a 2. So we really have 1 times 2, which ends up being a positive 2. So what do we have in the denominator? We have this 9 plus 2. So what is 9 plus 2? 11. So the answer is 11. Now that's not the answer. That's the denominator of our answer, right? 11's on the bottom. What's up on top? We still need to distribute 9 times 3. That's 27. 9 times I square root of 2. That's going to be a positive 9I square root of 2. And that all will be divided by 11. Okay, so that is your answer. However, if you do not see that on your multiple choice on the final exam, they may have split the denominator of 11 to each term. Okay, so they may have done 27 over 11 plus 9 I square root of 2 over 11. I'm not sure which way, but you need to know that if you don't find this answer, maybe they split that, right? Another way they could have written it, which I doubt, but they could have written it as 27 over 11 plus 9 square root of 2 over 11 with the I out here separately. They're really all the same answer. You need to know that if you don't see one of your answers, maybe they modified it. But I think this is the way they write it on the final, the original way we wrote it, okay? So here's another problem, exactly the same situation. Maybe if you saw me do it right now, you don't want to do it right now at this moment. You might want to wait to try it at home and then watch the video later. So what are we going to multiply both top and bottom by? By the same binomial, but with the opposite sign in the middle. 1 minus I square root of 3. Top also 1 minus I square root of 3. So up on top, 2 times 1, that's going to be 2. 2 times I square root of 3, with a negative in front, that'll be a minus 2I square root of 3. So that's what we have up on top. On the bottom, we have 1 times 1, that's 1. 1 times negative I square root of 3 is negative 1I square root of 3. You don't have to put the 1. You can just put negative I square root of 3. If you want, you can put the 1. Then distribute the positive I square root of 3 times 1 is a positive I square root of 3. Then positive I square root of 3 times negative I square root of 3, that'll be a negative I squared square root of, what's square root of 3 times square root of 3? Square root of 9, which takes you back to 3 at the end of it all, right? So we know that I squared is negative 1, and we also know that the square root of 9 is 3. So what we really have here is minus negative 1 times 3. So that's really a positive 1 times 3, which is really a plus 3. And we know that the middle terms eliminate. They're the same exact opposite values. And we have a 1 out here in the front. So let's put a 1 in the front. So in the denominator, we really have a 4. So this one, I know for sure that they're going to separate. So up on top, we had 2 minus 2I squared root of 3. On the bottom, we have a 4. I'm pretty sure they're not going to leave it like this on your answer, because 2/4 and 2 over 4 could also be reduced. So I'm pretty sure they will either split it and then reduce and make this a 1/2 and make this a 1 over 2. So they'll get 1/2 minus 1I squared root of 3 over 2. Or maybe they just reduce it all from this original answer, dividing everything by 2, reducing everything by 2. So that becomes a 1, that becomes a 1, this becomes a 2. So your final answer there would be 1 minus I squared root of 3 over 2. I'm not too certain. I'm thinking this is what it's going to be, but they could have also separated it, right? So you got to be prepared to see which is the correct answer. I mean, they're all correct, technically. They're just written differently. Number 22, factor the following. So this is just practice from chapter 4, factoring. The first type of factoring we learned was to pull out the GCF. That's the first type of factoring we should always try. And right here we could actually pull out the 4. And if we pull out a 4, what's going to be left? An a squared minus 2a minus 3. And if you look at the inside of the parentheses, we now have a quadratic trinomial where the a value is 1, not the original 4. It's the 1, which means if you have a standard form quadratic trinomial where the a value is 1, you could maybe factor it into parenthesis with your variables right there, and you simply think what times what is your c value that if you combine together is your b value. So what times what is negative 3 that if you add together is negative 2? A negative 3 times a positive 1. So guess what? Bring down that 4 in the front and you've completely factored. So let's do the same thing with 23. Let's pull out a GCF. What's a GCF on 23? 2. We can't pull out a 3 from 10, so yeah, 2 is the greatest common factor. And what would we have left over if I pull out a 2? 6x squared plus 7x minus 5. Now, unfortunately, right here in the middle, we still have an a value, which means we're going to have to do the longer process of multiplying a times c. So step 1 would be to multiply a times c, and we will get negative 30. Now, it's good that we pulled out the 2, because if not, a times c, you'd have 12 times that other big number. You get a huge number, so it's better to deal with this negative 30 than the other one. The only thing that you shouldn't forget is to bring down this 2 at the end once you're finished factoring. Anyway, step 1 is a times c, that's negative 30. 6 times negative 5 is negative 30. Step 2 is to make a list of the multiples of negative 30 that combine together to give you 7. How could I get negative 30? Negative 1 times 30. Negative 2 times 15. Negative 3 times 10. And you know what? The negative 3 and the 10, that's the right pair of numbers, right? So I could technically stop right there. I mean, I could have written negative 5 times 6 if I wanted to get the full list, but I already see that negative 3 and 10 is the right pair of numbers for step 2. That combines together to give us 7. Step 3 on this longer process is to write your factored form, and we want to put an ax right here and an ax right there, but don't actually write it, because what is ax? We need to identify what ax is. A in this case is 6. Don't go to the original. We're dealing with the blue one. The a is 6 with an x. So let's put 6x and 6x. And then we take that pair of numbers from step 2 and put them right into those parentheses, a minus 3 and a plus 10. And now that was step 3 of the longer process. Step 4 is to magically reduce each of the binomials by its GCF. And we say magically because we're not actually pulling out a GCF. We're just dividing it by whatever the GCF is, magically. So the first binomial we're going to reduce by 3. We'll get a 2x minus 1. If you divide the 6 by 3, you get 2. The 3 by 3, you get 1. Second binomial we're going to reduce by what? By 2. We're going to divide everything by 2. You'll get a 3x plus 5. Ladies and gentlemen, this is our factored form answer for this question 23. With a 2 in the front. Thank you very much. I just forgot the 2. Don't do that on your test. So final answer, 2 in the front, 2x minus 1, 3x plus 5. You need that 2 in the front, or else technically there's no way when you distribute you'll get back to the original quadratic trinomial without that 2. 24, same type of problem. What would I factor out first? 3. What would be left on the inside? 4a squared minus 1a minus 3. So on the inside, we do a times c. It's going to be a negative 12. And you think of the multiples of negative 12. Negative 1 times 12, negative 2 times 6, negative 3 times 4. That's all the possible multiples. Which ones combined together give us a middle value b, which happens to be negative 1. The negative 3 and the 4, that'll give us a positive 1, and we know we need a negative 1, so we have the right numbers, we just have the wrong signs. So switch it to a positive 3, switch it to a negative 4. Then when you go to your factored form answer format, we're going to write ax right here and ax right there, which happens to be, go with the blue one, right? We're doing the blue one, not the original. 4a and 4a. So let's do that. Write the 4a right there and the 4a right there. And again, in the blank spots, you put the pair of numbers from step 2, the positive 3 and the negative 4. Positive 3, negative 4. Step 4 is to magically reduce your binomials, magically divide them by your GCF. The first binomial, it has no GCF. There's nothing to divide by. The second one we could divide by 4. So our final factored form answer will be 4a plus 3. The first one stays. The second one's the one that becomes a minus 1. Don't forget about the 3 that's out in the front. Write that 3 out in the front, and there's your final answer for number 24. Moving on to 25. So number 25, they want you to state the discriminant. If you forgot what the discriminant is, it's simply the value inside the square root of the quadratic formula. So you have x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Notice that I put the b squared minus 4ac in red. Why? Because that is the discriminant value. This value tells you a lot. If you do this math in here and you end up with a negative, how many real answers are you going to get? 0, because if you end up with a negative, a square root of a negative is imaginary. If your discriminant happens to be 0, then you only get one real answer. Why is that? Because the square root of 0 is 0, and it doesn't matter if you add or subtract 0, your answer doesn't change. So if you had a 5 right here, 5 plus 0 is 5, 5 minus 0 is still 5. So you only get one real answer if your discriminant is 0. If your discriminant is positive, you're going to end up with two answers, because if you add a number and then you go back and subtract the number, you get two different answers. So it's important that we know all that stuff. So they want us to state the discriminant, and the only way to do that is to make sure that your equation's in standard form to begin with, so you could identify the B, the A, and the C. So let's get rid of that 11 by subtracting 11, and we're going to have your new quadratic trinomial equation, x squared minus 10x minus 11 equals 0. So if I did do b squared minus 4ac parentheses squared minus 4 times parentheses, and plug in my b value of negative 10, my a value of 1, and my c value of negative 11, what will my discriminant be? Well, b squared, that's 100. And then we have negative 4 times 1 times negative 11. That's going to be plus 44. So that will be 144. So this is my discriminant value, 144. Since the discriminant is positive, I mean, it happens to be a nice, beautiful, perfect square number, right? So I could technically square root 144, get 12. Then I'd go back and add 12 and subtract 12 and get two nice, beautiful answers. However, they don't want us to actually solve it. They want us to state the discriminant. That's the discriminant right there, 144. That's the number that would be inside the square root of the quadratic formula. And then it says describe the number and type of roots. So because our discriminant is positive, we're going to have two real roots, or two real x-intercepts, two real answers, two real solutions. Now, if my discriminant would have been negative, that would have been a negative 144, then you'd have imaginary values. So you'd have no real roots. You'd have imaginary answers. So let's continue on and do the same for number 26. Let's just plug it straight into b squared minus 4ac. That's the value inside the square root of the quadratic formula. So when I plug in 34 for my b, 1 for my a, and 289 for my c with the calculator. So when I do 34 squared, I get 1,156 with the calculator. And I know I need to subtract 4 times 1 times 289. And when I do that on the calculator, I also get the same value, 1,156. So my discriminant, I should probably write it out. My discriminant is 0. Okay? So imagine me trying to do the quadratic formula and this number ends up being 0. How many real answers am I going to get? One real answer. Whatever number this is, if I add 0 to it, it's the same number. And then if I go back and subtract 0 from it, it's still the same number. So you're going to get the same number. You're not going to get two different answers the way we normally would. So the discriminant is 0. Describe the number and type of roots. One real answer, or one real solution, one real root, one real x-intercept. Number 12, jumping right into the discriminant, b squared minus 4 times a times c. The b value is 11, a value is 12, the c value is negative 5. Again, this is the value inside the square root of the quadratic formula. So when I go 11 squared, that's 121. When I go 4 times 12, that's 48 times 5. It will be positive. We end up with 240 right there, and 121 plus 240 is 361. So my discriminant value is 361. It is positive, which would mean I'll have two real solutions, or two real roots, two real x-intercepts, whatever the multiple choice may say. The last one, you can't even plug it in yet because it's not set equal to 0. You need it to be in standard form. So first add 7x, rewrite your standard form quadratic trinomial equation, 6x squared plus 7x minus 3 equals 0. Now you could identify your a value of 6, your b value of 7, your c value of negative 3. So now let's plug it into that b squared minus 4ac. b squared minus 4 times a times c. Again, this is the value inside the square root of a quadratic formula. So the b value is 7. A value is 6, C value is negative 3. When you do this math, hopefully use a calculator, 49, you end up with a plus 72? No. 72. And 49 plus 72 is 100, what? 121. Okay, so the discriminant is 121, which means we're going to have 2 real solutions. They're not even asking us to actually find those solutions. They just want to know what your discriminant is and how many real solutions you have. There's going to be one question and one question only out of the 30 of the final exam that has this data shown on a table. It's not going to be the exact type of information, minutes and calories. You might have like rainfall and inches, or I don't know, whatever the information may be. But they want us to create a prediction equation, and they specifically tell us to use the first and fourth ordered pair. So normally we have x, y values, and these are x, y values, but instead of x's we have minutes, and instead of y values we have calories, right? The minutes are the inputs, the calories are the outputs. It depends on how much time you work out. That'll give you how many calories you burn. So they want us to use the first coordinate and the fourth. Okay, so the first coordinate is 17, 133. The fourth coordinate is 42, 409. So they want us to write a prediction equation. First of all, a prediction equation, in this case, is going to be a line that best fits, and it's going to be in y equals mx plus b. Or you could use point slope form also, y minus y1 equals m parentheses x minus x1. I hope we remember this. Anyways, either form, we need slope. So to find slope, we're going to use the slope formula, which I hope you guys remember. The slope formula is y2 minus y1 over x2 minus x1. This was from the first 9 weeks, from the beginning of the school year. We had this on our midterm exam also, and on our midterm review. So hopefully we remember this. One coordinate has an x and a y value. The second coordinate also has an x and a y value. So how do we tell the difference? We're going to call the first x and the first y x1, y1. The second x and the second y, we're going to call it x2, y2. So when we plug it into our formula, I would do the division and the subtractions first. That way you don't get confused. And then I plug in y2, which happens to be 409, minus y1, which is 133, over x2, which is 42, minus x1, which is 17. Could somebody tell me with the calculator what 409 minus 133 is? Thank you. 276. And on the bottom, 42 take away 17? 225. Okay. No, 25. Wow. Sorry. I said 225. 25. All right. So that is our slope. Could somebody actually divide 276 by 25 for me on a calculator? It's going to be a nasty decimal. Huh? 11.04? And it doesn't repeat or anything? No. Okay, so 11.04. So we're actually going to leave it as a decimal value. Okay, so this is our slope right here. This is our m value. So we need to write an equation either in slope-intercept form or point-slope form. In order to write it in slope-intercept form, you need a slope and you need a y-intercept. We do not know the y-intercept. What do we have here? We have some points. So we have a point and a slope. We might as well go with point-slope form. If you remember point-slope form, it's y minus y1 equals m. I'll put the m in red this time. Parentheses x minus x1. Okay, so let's plug in our y1 value, which happens to be 133. So we're going to have y minus 133 equals m equals, we know the m value is 11.04, open parentheses, x minus x1. We know that the x1 value is 17. So we'll put a 17 right in there. Close parenthesis. Now, I believe you're not going to see this point-slope form equation on the multiple choice. I believe they changed it to slope-intercept form. So you'd have to distribute 11.04 times x. That'll be 11.04x. 11.04 times 17. Could somebody give me that value, please, on a calculator? 187.68. Thank you for the calculator help. And now we still have the equal sign and the y minus 133 in the front. So let's add 133 to get the y by itself, and add 133 to the negative 187.68. So somebody with the calculator, please go 133, take away 187.68. So if you do this correctly, you have y equals 11.04x minus 54.68, right? So this is our prediction equation. This is our prediction equation. And further, you're going to have to identify this prediction equation on your multiple choice. And then in addition to that, they're going to give you the missing output. So as you see up here, we have a 60 for the input and it has a missing output. So what we need to do is plug in that 60 to find out what the output's going to be. So up here, we're going to say y equals 11.04 times that input 60 above, and of course with the minus 54.68 to find the output. So with the calculator, go ahead and do 60 times 11.04, hit equal, and then subtract 54.68 to give me a final answer for my output. So we have 607.72. So this would be your output for the given input. So in addition, on your multiple choice, they're going to give you this equation, and you might have two of these guys with different missing output values. So of course, you need the right equation and the right output on that multiple choice question. Now, because this video is already over half an hour, I'm going to skip number 30. You could look at the answers that I provided to see if you could do this correctly. All you need to do is do the same exact process, but they want us to use the first and third order pair. So use this one as x1, y1, and this one as x2, y2. That will change your answer slightly. And you could check the answers that I posted on Edmodo or on the back door right there. So you could do that on number 30 on your own. Let's move on to this next section. The next section is back from 4.1, I believe, which was just the rules of exponents. And we need to remember that a power to a power you multiply. If you ever have a power on the outside of the parentheses with no addition or subtraction inside, you could distribute it to both. And we also need to remember that any exponent that's negative, that term must be circled and moved to the other side. Okay? So this is what I want to do. I want to begin with this first parenthesis. You have an x to the negative 7. I'm going to put an arrow on it. I'm going to draw an arrow down. I want to also circle the y to the negative 3 and put an arrow going down. So this new first part, it's going to be a negative fraction. What's up on top? The 3 did not have a negative exponent, so the 3 stays up on top. The x to the negative 7 comes down and it becomes x to the positive 7. And the y to the negative 3 also comes down and it becomes y to the positive 3. Whenever they move, the exponent sign changes. Now on the second one, the second term, we're going to distribute that 2 to each of those terms. So instead of 6x squared, what should I write? What's 6x times itself? So I'm going to put times 36x squared, right? And if you wanted it in the form of a fraction, you could put it over 1. So let's multiply the top with the top and the bottom with the bottom. So my new answer will be 3 times 36. I don't know, what is that? It's 108? 108? And not only that, a negative fraction times a positive fraction is going to be a negative. So we're going to have a negative fraction. Up on top we have 108. We also have the x squared up on top. So let's put the x squared up there. Then we also have on the bottom the x to the 7th y to the 3rd times 1. It's still x to the 7th y to the 3rd. So for our final step here, we need to cancel out x's. So let's cancel out these 2 x's, completely cancel out with 2 of the 7, and you will have 5 left. There's our final answer, negative 108 over x to the 5th y to the 3rd. Moving on, number 32. Number 32 is a little easier. All you're doing is distributing that 6 into each power. So it's not 2 times 6. There's an invisible 1 right there. It's really 6 times 1. That way you'll end up with 2 to the 6th. And then 6 times negative 4, you'll have f to the negative 24, power to a power. You multiply. And then after that, the negative exponents must move down to the other side. So up on top, I have 2 to the 6th. But what is 2 to the 6th? That's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64. So you have a 64 up on top, and on the bottom you have f to the 24th. There's your answer. 33. 33. There are no powers on the outside of the parentheses, so you don't have to distribute anything, but we do have negative exponents. So let's move those negative exponents down to the bottom. Or we could follow a different rule, right? Instead of saying, oh, I want to move the negative exponents down to the bottom, I'm just going to multiply this guy times this guy. Let's try a different route this time. The other time we moved negatives down first. This time let's actually multiply top with the top. So right here we have 4 times negative 5. What's that? Negative 20. And then we have d to the second times d. What's d to the second times d? D to the third. And then we have t to the fifth times t to the negative 3. What's 5 plus negative 3? T to the second, right? 2. And then v to the negative 4 times v to the negative 1. What's negative 4 plus negative 1? V to the negative 5. So it was actually more convenient to just use rule 1 where you add exponents on this one, because instead of moving a bunch of things around, all we're really moving is this guy down at the end. So our final answer will be negative 20 d to the third t to the second over v to the positive 5. Moving on to number 34. They want us to solve. There are no more exponents here. Right here, they want us to solve. So we do have a quadratic, but it's best to set it equal to 0. So let's add 2, and we will have the quadratic trinomial equation x squared minus 2x plus 7 equals 0. Now, on this problem, it'd be good to try to factor what times what is 7, that if you combine together is negative 2. There is no answer that works. So we're solving, though. It's not like they're asking us to factor. Even though this is not factorable, we could still solve it. Solve it using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And when you use this formula, please use parentheses to replace your b's, a's, and c's. So you have b squared minus 4 times a times c, all divided by 2 times a. And of course, the a value is 1, the b value is negative 2, and the c value is 7. So the b value of negative 2 goes right there and right here. The a value of 1 goes up here and down there. And the c value of 7 goes right there at the end. So let's zoom in on this quadratic formula. We're going to begin by simplifying the discriminant value. So we have negative 2 squared, that is 4. And then 4 minus 4 times 1 times 7. That's really a 4 minus 28. So what we really have inside the square root is 4 minus 28, which is going to be a negative 24. Everybody agree with me? And we also have the plus or minus right in front of it and a positive 2 out in the front, all divided by 2. So the question is, could we simplify this radical, the square root of negative 24? The square root of negative 24 is really an I on the outside times the square root of 24. 24 is not a perfect square number, but you could rewrite it to get a perfect square number, 4 times 6. That way when you split it, you could actually do the square root of 4, which is 2, and then you have the square root of 6, which can't be simplified any further. Don't forget about the I, that you need to come down and multiply it by 2. So the square root of 24, of negative 24, it really becomes 2i square root of 6. So what do we have here? We have 2 plus or minus 2i square root of 6. And it's all divided by 2. So we have 2 terms that are being added or subtracted, all divided by 2. So you could split that 2 and divide each of them by 2. And your final answer will be, it's kind of like reducing all by 2. Your final answer will be 1 plus or minus I square root of 6. That's your answer. If If I were to think about the graph, this parabola would not cross the x-axis because we end up with two imaginary answers. Let's try 35. Again, you want to make it a standard form quadratic trinomial first, set equal to 0. So add 6 to both sides. You'll have 5x squared minus 6x minus 1 equals 0. And you cannot factor it. What times what is negative 1 that if you add together is negative 6? You can't factor it. So again, you're going to have to rely on the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Where the a value is 5, the b value is negative 6, the c value is negative 1. So you have a negative 6 right here, a negative 6 right there. A value of 5, negative 1, a value of 5. So we really have a positive 6 plus or minus. This is 36. 4 times 5 is 20 times 1 is 20, and a negative times a negative is a positive. So you really have 36 plus 20. Of course, you could do this with the calculator. You end up with 56. So what we have is 6 plus or minus the square root of 56, all divided by 10. And the square root of 56, it's not a perfect square number, and you got to think if you could break it down with multiplication to get a perfect square number. And I believe it becomes 4 times 14, I believe, would give you 56. So you'd split the root. You'd have 2 square root of 14. You can't really break down 14 anymore. So you really have is 6 plus or minus 2 square root of 14, all divided by 10. So reduce all by 2. That becomes a 3. This becomes a 1. This becomes a 5. And there's your final answer. 3 plus or minus square root of 14, all divided by 5. Number 36. Once again, move that 4 over to the other side. You're going to end up with negative 4x squared plus 8x plus 1 equals 0. Now we could identify a, b, and c. We're going to use a quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Where the b value is 8, the a value is negative 4, and the c value is 1. And you're going to work on the discriminant. 8 squared is 64. Negative 4 times negative 4 is positive 16. Times 1 is still positive 16. So what we really have here is negative 8 plus or minus the square root of 80, I believe. And it's all divided by negative 8. So the square root of 80, it's not a perfect square number. We need to break it down with multiplication to get a perfect square number. So the square root of 80, we're going to rewrite it as 16 times 5. 80 is 16 times 5. Split the root, that way you get 4 square root of 5. So what we really have here is negative 8 plus or minus 4 square root of 5, all divided by negative 8. And you could reduce everything by 4. So when you reduce by 4, you get a 2. Reduce by 4, you get a 2. Reduce by 4, you get a 2 square root of 5. So your final answer here is a, by the way, the negative on the bottom, the negative on the top becomes positive. And yeah, this negative with that changes the sign, but it's a plus or minus, so it doesn't really matter. So we're going to end up with 2 plus or minus square root of 5 over 2. That's your final answer for that one. We're going to stop this video right here and start another video on page 3 of the practice final.